So today I'm going to talk you through the processes of simple factorising. It's a skill that's required within algebra to either simplify statements or to simplify slightly more complex algebraic terms, possibly involving fractions, and possibly it's a step you might need to use within an equation solving scenario. So first of all, what is factorising and what are factors? Well, you should be used to simplifying numbers and listing factors of numbers. So if we take a simple example, let's take the number 35, and I can rewrite 35 as 5 multiplied by 7. And so what I've done here, the important analogy for our algebra here, is that I've rewritten 35 as a multiplication, and it's a multiplication of the two factors 5 and 7. And in algebra, when we refer to factorising, what we're often looking to do is to rewrite the algebra statement as a multiplication. So, simple example, 10a plus 25. So if I look at these two terms, what I'm looking to do is try and spot something that's common to those two terms, a number that would divide exactly both of those two terms. I can look at both the number aspects of this and the algebraic aspect of this. Well, the first term, 10a, has an a in it and a 10, and the second term is just a number 25. So at this stage there's no algebra terms to pull out, but I can spot that 10 and 25 both divide by 5. So I write down a 5. 5 times what makes 10? 2. And I need a 10a as my term, so I've got to put down an a as well. 5 times 2a would make 10a. Plus 5 times what makes 25? Well, that's a 5 as well. So I've rewritten that expression as a multiplication of 5 and the bracket 2a plus 5. So I have factorised this expression. Note that I used 3 dots to represent therefore. I didn't use equals because this isn't an equation I am solving. Second example. So in this example, I've deliberately created a situation where on inspection the numbers 3 and 7 don't share a common factor, not like 10 and 25 did. I can't do anything with those, but when I look at the algebra, x squared and xy, well, x squared means x times x and xy means x times y, so I can factorise out the x because that's common to both terms. Now I've got to think to myself, what do I multiply x by to get 3x squared? Well, I need another 3 and an x. 3x times another x is 3 lots of x squared. Plus 7xy, I've already got the x, I just need 7y to complete my factorisation. Underline my answer. Third example. Sometimes in a question you might be able to extract both a number and a bit of algebra from the question. So let's have 6pq minus 15qm. So when I inspect these two terms, looking at the numbers, the coefficient, the 6 and the 15 are both divisible by 3. So I can first of all extract a 3. Then looking at the algebra bits, I've got a PQ and a QM. There's a Q common to both terms. Let's bring that outside as well. Nothing else that I can extract. So let's think about the contents of my brackets to rebuild this question. 3Q times what would make 6PQ? I need to multiply the 3 by a 2 to get the 6, and I need to have a P there as well to make sure that these two bits multiply back together to give me that term. 3 2s are 6, PQ, PQ. This time it's minus, we'll match that in the bracket. 3 times what makes 15? 5 times 3 makes 15. I already have a q. I need qm. So if I put an m there, then my factorization is complete. Now let's just talk briefly about what a complete factorization means. Because it's quite possible you might have done example 3 like this. 6pq minus 15qm. You might have scanned this and gone, oh look, q in both terms, I know what I'm doing here. Q brackets 6p minus 15m, job's a good one. But this would be an incomplete factorization. And that's an incomplete factorization because when you inspect the bracket, you realize that what you haven't done is you haven't taken out the 3 that divides both of those terms. So you haven't listed this, you haven't stated this algebraic expression correctly as a product of its factors. You've left one of them inside the bracket. So what you've done isn't technically wrong. These statements are still equivalent, but it's not fully factorized. That's what it should look like for that question. All right, let's do one more. Let's just put, no, okay, EG4. Sometimes you get more than 2 terms, and sometimes you can have all sorts of bits of algebra there as well. So let's make something fairly horrendous. Let's go for 24x cubed y squared plus 30x y to the power of 5 minus 12x to the power of 4 y to the power of 3. Now, we've got 3 terms. The 3 terms all have a number, some x's multiplying and some y's multiplying. Now, just to avoid any confusion here, and you wouldn't normally do this step, I'm going to write down these terms slightly unusually. 24 x, y, y plus 30 x, y. Why am I doing this? You'll see in a minute. Minus 12 x, y. So what I've done is I've written each of these terms down, and I've kind of exploded what's going on with the powers. And that will allow you to see how many x's and y's visually there are in each term, and it will help you to visualize the factorization. So let's look at the big numbers first of all. Hopefully you'll realize I've chosen numbers that are all in your 6 times table. So we're able to extract a factor of 6. Next, all of these terms contain some x's and some y's, but I can only take out the lowest number of x's from each term. I can't take out x cubed as a factor. I mean, I can from that term, and I can over here, but this term doesn't have enough x's to do that. The minimum number of x's in each term is just 1, so I can only take out 1x. Now let's look at the y's. 2 there, 5 there, 3 there. 2 is the minimum number. I can take out 2 y's multiplying each other, so y times y is y squared. And then I've got to go back and rebuild my terms. 6 times what makes 24? Well, 6 4s are 24. I've already got 1x here, and I need 3 x's multiplying in my term, so I need another x squared there to build it back up to x cubed. And I've already got the y squared on the outside here, so I don't need to put any more y's on this term here. Let's focus on that second term now. 6 times what makes 30? Well, 6 times 5 makes 30. I already have an x on the outside, and I've got y squared, so I'll need 3 more y's all multiplying each other. That means 5y cubed for that term. And then the last term, I'll need a minus 2, 6 times minus 2 would be minus 12. I have an x here, and there are 4 x's multiplying in this term, so I need 3 more x cubed. I already have a y squared on the outside, and I need 3 y's multiplying here, so I'm going to need 1 more y for that term. And there we go, I have factorised that fairly horrendous looking expression. Hopefully it won't get any nastier than example 4 initially. Thank you very much.